Okay, hello, this is Mr. Yo here. So this is how we're gonna work on worksheet 6.4. What we're gonna do is you're gonna listen to this video, and then I'm going to give instructions along the way in this video, and you just have to follow accordingly. At some moments I'll ask you to pause the video and try it yourself, and then look at the solutions. At others, you just listen along and write the solutions along the way. So if you have not done so, write down your name and your class and your date, and then we're gonna start on the rest of the worksheet. But before we begin, before we start on problems involving trigonometric ratios, we have to recall our tua ka so. So let me just write that down, and this is what we call a mnemonic, and a mnemonic is just a way to help us to remember some formulas easily. So tangent means tangent theta is equals to O and A. That gives us opposite over adjacent. Cosine theta will be A over H, which is adjacent over hypotenuse. And finally, sine theta is opposite over hypotenuse. Okay, so we will need to refer to this a few times, because in each example we will see some right angle triangles where we will need to use tua ka so accordingly. So let's try one. Here the diagram shows a helicopter C hovering vertically above the point B on a horizontal ground AB. AC makes an angle of 30 degrees, okay, which they have labeled here, with the ground AB. If AB is 200 meters, how high is the helicopter above the ground? So they're kind enough in this case to draw out a triangle for you here, and therefore you just need to identify where is the opposite, adjacent and hypotenuse of this right angle triangle. So it shouldn't be too difficult to identify this as the adjacent, this as the opposite, and this as the hypotenuse. Well, let's see what we are looking for. We are looking for how high the helicopter is above the ground, which means we are looking for the length BC. Alright, we are not looking for the length AC, we are looking for the length BC. And so we are going to involve ourselves with using the adjacent to find the opposite. Right? And then we have the angle 30 degrees. Therefore, we are going to think of tangent. Tangent theta, or tangent 30 degrees in this case, is equals to BC over 200. So making BC the subject, all we have to do is write BC is equals to 200 tangent theta, tangent 30 degrees by multiplying 200 upwards. And if you press your calculator, checking that it's in degree mode, you will get 100 meters. Do not forget your units. So that's all for let's try one. Let's move on to question 2. Now a hot air balloon B is vertically above the point D on a level ground ADC. Alright, usually what this means, here we have the word vertically above, just like in the previous example, vertically above, that means we are creating this 90 degrees angle over here. Same for this case. Okay, so that's what it means. Is especially, you need to know this especially if the diagram is not given to you. You have to draw out the triangles yourself, but here it's already given to you. So given that AD is 120 meters, BC is 280 meters, and BAD is 57 degrees, fine, let's do part A first, the height of the hot air balloon above the ground. So what are we looking for? We're looking for the length BD in this case. Alright, so let's work on that. Well, we have 120 degrees, 120 meters, 57 degrees, and we're looking for BD. Identify the sides of the triangle with respect to 57 degrees. So this should be adjacent, opposite, and hypotenuse in this case. Okay, when we're looking at triangle ADB. Okay, so now let's find the height. Well, we want to find opposite and we are given adjacent, so we're thinking of tangent. So tangent 57 degrees is equals to opposite, which is BD, over AD, or 120 meters. So BD is just 120 tangent 57 degrees. Press your calculator. Alright, you will get a long string of numbers. we might need to use it later on for part B and part D. For part B and part C. So let's write it all out first. 184.78379957. Let's round this off to 3SF because we need to give our final answer. So we'll get 185 meters. Okay, let's look at, once we've obtained this, let's label that down. Okay, I'm just going to write 185 for BD, and that will be useful when we solve part B. So now we want to find angle BCD. Where is angle BCD? We are looking at this angle over here. Okay, so now in this case, we want to look at this triangle. I'm going to label it with my blue line. Alright, this is a blue right angle triangle, and in this case we want to find this angle here. So with respect to this angle, this is actually the adjacent, this remains as the opposite, and this is now the hypotenuse. And we want to find this angle. Well, we have the opposite and we have the hypotenuse. Right, so let's do this. Opposite and hypotenuse, we're going to use sine angle BCD is equals to 1. Well, we need to write more than 3SF. So if you were to write it all out, that's fine. You want to leave to 5SF, that's fine as well, as long as it is more than 4SF. Okay, so 184.78 over 280, and then make BCD the subject, meaning to say we need to bring this sine over. So remember in the previous worksheet, when we bring over the sine, it becomes a sine inverse. So if it becomes a sine inverse, then you have your 184.78 over 280 inside the brackets. Press your calculator, you will get, let's write something longer than the 3 degrees. So 295, and then when we round off, sorry, not 3 degrees, 1 decimal place. So let's round off to 1 decimal place. We will have 41.3 degrees. 1 dp. Okay, so finally let's find the distance AC. So the distance AC is from the left all the way to the right. Okay, the entire length of the triangle. So well, we already know that AD is 120 meters. So all we are left is to find DC. So if you want to find DC, there are a few methods that you can use. Okay, you can use the angle that you just found together with the hypotenuse, or the length that you found in part A together with the hypotenuse. I am going to use the length 185 with 280, and we're going to use Pythagoras theorem in this case because we have two lengths and we're finding the last length. So let's write this down. By Pythagoras theorem, okay, we have BD squared plus DC squared equals to BC squared. Let's do the substitution. So BD was originally 120 tangent 57 degrees. So I'm going to write that down. Okay, this is of course the most accurate value. You can also use 184. You can also use this one over here, 184.78379957. It's up to your preference as long as you take more than 4SF, plus DC squared, which is what we're looking for, equals to BC, it is 280 squared. So make DC the subject. DC is equals to square root of 280 squared minus 120 tangent 57 degrees. There should be a squared here. Okay, and press your calculator, you will get 210.36866203. Now we want to find AC, meaning to say we need to add AD plus DC. So 120 plus 210.368023, we will get our answer 330 meters, 3SF. Alright, so this is question 2. Move over to the next page. Before you watch the video, I want you to try Mastery Practice 3 yourself first. So press pause, do the working, and then once you're done, press play again and then watch the video. Alright, so far all you're doing now is identifying the right angle triangles. Okay, so press pause now. Alright, so you should have finished the question mastery practice 3 by now. I am going to go through it. Let's look at this question. Arun wants to find the height of the tree. So what are we looking for? We're looking for this. Alright, you need to identify this first. Wants to find the height of the tree. Find the height of the tree. Okay, he stands 125 meters away in front of the tree, so that's 125 right here. And then he measured the angle, which gives you 24 degrees. His line of sight makes an angle 24 degrees with the horizontal, so that's labeled right here. And Arun's eye level is 1.5 meters above the ground. So find the height of the tree. Well, you would need to identify and split this height into two parts. The first one being this one here, and the second one here, where you know this to be the same as this length, which is 1.5. So all we're doing is, if we can find this, we just add them up and we get our answer. So, well, you need to identify that there is a right angle triangle in this case. Okay, I'm drawing the 90 degrees here. Okay, so there's a right angle triangle. And the angle is 24 degrees. We have, in this case here, the adjacent, the opposite is here, and this is the hypotenuse, right? So we're looking for the opposite, and we have the adjacent, meaning to say tangent 24 degrees is equals to opposite. Well, I don't wanna label it opposite, so I'm just gonna give some names. Let's call this A, this point here B, and this point here C. So I have BC over 125. So making BC the subject, I have BC equals to 125 tangent 24 degrees, and that will give me 55.65358566. Alternatively, you can choose not to press the calculator and not write this down first. When we find a height of 3, that will give me this part here, BC, plus C, let's call this point D. So BC plus CD, BC is 125 tangent 24 degrees, plus CD, it is 1.5 meters. And when you add them up together, you will get 57.2 meters 3SF. Okay, so once you're done with this, go ahead and try the what's the question. I will be going around and helping your friends. Once you're done, let me know. I will tell you whether the answers that you have obtained in what's the question is correct. And then if you're done and I'm still not ready, you can go ahead and do the homework questions first. Alright, that's all. Thank you.